facilitate what we're doing. A lot of what we do here on this side is going to be like thinner sheet metal type product. Thickest stuff we're doing is stuff like this in the 3/16 to 1/4 inch range for anodes. We got kind of just basic equipment, some shears, spot welding, type of stuff. I'll show you guys, since you're in the anode type one, let me kind of show you what we're doing over there in the anode.
Okay.
So we do a variety of stuff with the anode. Obviously we do new products as well as recoats.
Okay.
So one of the nice things about these mixed metal oxide, they're dimensionally stable anodes.
Okay.
So in most applications, the substrate is a constant. It does not break down or degrade over time. Like this product here, these are sheets that are used for the electrowinning of nickel. We apply an iridium oxide to this.
Okay.
They go into their process up in Canada. They run them for roughly 2 years. At that point, the iridium is spent. They send them back. We strip them. We remove the hanger tab. These are the conductor bars where they apply the current. And then we actually are able to recoat these.
Okay.
And we can get about 4 coats out of them before they're done, before the material has just thinned out to the point of it not being.
When you coat ours, they're going to last a long time.
Okay, great.
So, and that's awesome.
So
okay.
yeah, that's kind of the product that we do. It's all variety of stuff, but this is a big customer of mine right here.
Okay.
We do all types of shapes and configurations. So this here is another type of product we run regularly. These are going to be anodes and cathodes. These ones here are cathodes, but these are all used in water purification. So this goes to municipalities. And what they do is they take the water from the sewage treatment facilities, what they would call the gray water or whatnot. They use these electrolyzers, so it's a cell of anodes and cathodes that are coated. You introduce the brine, which is this gray water. The reaction between the catalyst, which is the anode coating, the cathode coating, and the process when you add electricity is a byproduct. The byproduct here is chlorine. So these are chlorine generating systems for this. So basically you can take, a lot of this work goes on the boats. So for anti-fouling equipment, so if they're pumping seawater in for fire suppression or cooling or anything like that, they have these electrolyzers on board. They run the seawater through. The unit creates chlorine, kills any of the living organisms that are inside of that seawater, and then they can use that seawater throughout the vessel for different applications. Same concept for municipalities. There is some that's done for desalinization, but very little at this point. Most desal is done other options with RO and things like that. So that there is a bipolar, is what we call this. So we have an anode and a cathode coating on this one.
Okay.
That are each designed specifically for the application. All right, so the way this works is it's a stack. So you have an anode terminal, which is here, where the electrical current is applied. And you have a stack of bipolars in the middle. And you have the cathode at the end.
He used the C.
Right.
To have the C on there don't work.
What's that?
If you don't have the C, it doesn't work.
They don't know which way it is. It doesn't work. They put it in backwards every time.
Then you got the wrong.
It really won't work.
Then it becomes a non-power.
Well, then they call me back and they go, hey, why is the coating all gone after this first day? It's like, well, you have the current reversed. You know, that's what happens. But so the way those work is they stack them up, current's applied, and the current transfers because of the because of the electrolyte. You're able to transfer current. It goes from anode to the bipolars and vice versa from the cathodes to the bipolars.
Yeah, you're going to need this kind of technology later on.
What you're going to find interesting is in this electrolytic process, because of the circuits I developed, even in sodium chloride, we produce 0 chlorine.
Really?
Really.
Interesting.
Yeah, it's very, very interesting. But a lot of my friends use the bipolar plates when they stack their batteries.
Yes.
So that's why we're able to just do anode and cathode in a parade like this, because it's a completely different energy platform that we put in.
Okay, cool.
So, but this is valuable for us for other things, the battery design, for water purification.
Yeah, definitely.
Which we call our HydroMe project, where I was explaining the large shipping container. So we're definitely on board with this with you with water purification. Okay.
And we have a variety of coatings that are our own patent for coatings that are for a variety of applications, right? So
Right.
this is strictly a chlorine generating coating.
What is the base metal?
All of them are titanium. All
Right.
right, yeah, all of them are titanium substrate. Yeah. Hey, Ruben, I'm gonna get those two,
Okay.
the rods, I believe, are just like the ones you're looking for.
Okay.
Oh.
I can't believe it. That's worth a lot of money.
Yes, it is. So these are the rods.
Oh. May not be exactly the same, but
Yeah.
probably very similar to what you guys are looking for.
It's exactly what we're looking for.
Yeah, so I do, right now I only have about 5 in production. I'm doing some test coatings for a guy. We're doing 5 different coatings so we can do some testing. But I've run thousands upon thousands of these parts.
So the rod is this diameter on the end, and the coating is the buildup?
No, sir.
It looks like a welding rod.
No, they've been machined down.
Yeah, the rod starts at, these are, I think 5/16.
5/16. This is the size we're
Starts
talking
at
about.
5/16. Then we machine the groove in there for the O-ring, and we machine the threads.
Okay.
And then we apply the coating. The coating is a very, very thin layer, to be
Oh, that's
very
what I was
honest with
wondering.
you.
Okay.
It's
This
not
is
even a micron.
exactly what we need, just to the spec length that we're asking
Yeah.
for. Exactly like that.
Yeah,
Exactly.
no problem. Like I said, I've done thousands of these this year.
Well, you're going to do thousands more.
That's great, man. We love it.
Cool.
So that's an uncoated.
Thousands more.
No problem. That's an uncoated one right there.
Okay.
And just so you can see, I'll show you about that coating. So that's the titanium substrate there, the metallic area. The coating is all done on a weight gain basis, right? So all the coatings are designed on a X number of grams per meter squared weight gain. That's how it's all applied. But in terms of true thickness, it's nothing.
Yeah, right.
Right? It's not even a micron in most cases.
Okay. But is it just clad over the top?
I'll show you how. It's a
It's
paint
just
process.
clad, but it's
It's not clad. It's a paint stove process. So let me put this back up here.
Pretty cool.
Yeah.
That saves us a whole shitload of trouble.
Okay.
So what we do, the basic premise of the coatings that we make, we take metal salts, all right? We break down the metal salts using a variety of components, either alcohol or acidic. We have a couple other components that we add to these coatings for stability.
Okay.
And what we get is what we end up with is basically a paint. Okay? We develop these paints. We then dictate to the guys out here on the floor how much is to be applied. Okay? So there's a specific amount of coating that's applied during each coat. Because you cannot apply all of the coating at once because you'll have poor adhesion.
Right.
So the way we found for the most durability and longevity of this product is you apply it in multiple cycles, multiple thin cycles. So we apply a thin layer of paint, it goes in the oven, it becomes thermally deposited. Once that's dry and cool, it comes back and we apply another coat. And we repeat this cycle until we achieve the weight gain that's required to maintain the lifetime that's required for the anode itself.
Got it.
They're all done the same way. Every anode that we have, but we have a variety of coatings. So right now the guys are coating 2 main coatings. These parts here are ruthenium oxide coating.
Okay.
The parts of this gentleman's coating over there, those are on iridium oxide based coating. All the hydrogen projects I've worked on previously have been iridium oxide
That's
based
exactly
coating.
what I'm going to spec for you. Okay. Perfect.
This is where we do all the coatings out here. Yeah, all thermally deposited, variety of shapes. All kinds of stuff. We have testing capabilities in-house.
Okay.
We can do life cycle testing. All right. We do signal electropotential to basically ensure that the product going out the door meets the electrical requirements of the product. And all that's done on every one.
All right. Thank you.